All right, guys, so the topic we're introducing in 3.4 is something that's probably brand new to you. It's very similar, actually, to what we did in section 3.1, except section 1 only had x's and y's in 2 equations. Now we're going to have x's, y's, and z's in 3 equations. So instead of 2 equations in 2 variables, we are going to have 3 equations in 3 variables. So this first definition that you should have on your vocabulary sheet, an ordered triple is something x, y, z. And it has to be in that order, just like an ordered pair, except it's an ordered triple. We're now going to be working in 3-dimensional space instead of 2-dimensional space. And so each equation, x, y, z, instead of being a line, is actually what we call a plane. So all of these spaces that basically look like they could be a sheet of paper, kind of bent in a different direction, all of these spaces are called planes, and they're the result of an x, y, z equation. So when we're looking for the solution of a system like this, there are 3 possibilities. Option number 1 is that there's one solution. You've got 3 planes and they are intersecting at a specific point. One point that all 3 of the planes have in common. Infinitely many solutions. We've got 2 options here. Either they all intersect in a line, so all 3 of the planes have one line in common. You can see that almost looks like a pinwheel there. And so there are an infinite number of points on a line, so there are an infinite number of solutions. And then this situation here is when they're all the exact same plane. So they all intersect and they end up being the exact same plane. That's similar to what we saw in 3.1 when the lines were just right on top of each other. So in 3-dimensional space, that's the analogy for that. No solution, you've got a bunch of different situations here, but basically what it means is that there's nothing that's common to all 3 of them. Like here, these 2 have something in common, these 2 have something in common, so do these 2, but there's not a single point that all 3 lie together. Same with this, we've got 2 parallel planes and one that runs right down the middle, and here we have 3 parallel planes that have no intersections whatsoever. But either way, there isn't a single XYZ point that all of them have in common. So these are some different ways this could look. So just to give you kind of a visual of exactly what we're going to be dealing with, let's get into the algebra. Okay, so basically what we do with these examples is we do the elimination method. So I'm going to write that up here. So we're going to do the elimination method. So similar to what you guys were doing in example 1, except it's going to be like the elimination method on steroids, basically. So we've got 3 different equations. All 3 of those equations have 3 variables. There could be some in the future that only have 2, but we'll deal with that as they come. So to keep our organization, we are going to label these equations A, B, and C. That way I don't have to say 5x plus 3y plus 2z equals 2. I can just say A, and we can deal with that. So the way this works is we are going to do 2 rounds of elimination. 2 rounds of elimination are going to get us down to just 2 variables. Okay, so step 1, we are going to do 2 rounds of elimination. Eliminating the same variable each time. That part is absolutely imperative. Okay, so what we're going to do is we're going to pick a variable that looks like it's pretty easy to eliminate. And all these ones are not bad. Like we could eliminate this x by multiplying it by 2 to cancel with this one, multiplying it by, or negative 2, multiplying it by negative 5 to cancel with this one. We could do the same thing with this y, multiply by negative 3 to cancel here, multiply by negative 4 to cancel here. Or the z, we could multiply by 2 to cancel here, or 2 to cancel here. So to me, that z looks like it might be easiest. So what we're going to do is we are going to take equation A, right here, this first one, and then we're going to take twice equation B so that the z's will be opposite. Okay, so plus twice equation B. So this is how I want you guys to keep yourself organized. I want you to write down exactly what you're doing. So I'm going to write equation A exactly as it is. Okay, and then I'm going to double equation B. So 4x, 2y, minus 2z equals 10. Make sure you double everything. That'll be a really quick way to kind of throw your answer from the start if you forget to do that. So combine everything up. I've got 9x, 5y, my z's will cancel, equals 12. Okay, so now I just came up with an equation with two variables. I'm going to label this guy D, okay, because I'm going to come back and use it later. So now I'm going to do a second round, again, eliminating the same variable. I haven't used C yet, so I definitely have to use C. So I will start with equation C. This has a 2z. I can do the exact same thing and make this a negative 2z again. So I'll combine that with 2b, just like I did in the first round. So copy down C, no changes necessary. And then write down this same equation right here. That's double equation B. Okay, so same thing. So combine the x's, I get 5x. Combine the y's, the z's will cancel, and then I get 26. So this is going to be equation E. All right, so that was step one. So now I'm in a familiar place. Like if I had given you just these two in section 3.1, we could have worked with that. So now step 2 is to basically solve the system of two equations. Oops, that should be a W, which is not a very good one. So solve the system of two equations. So basically whatever you did in section 3.1, do that so you can solve for x and y, or whatever two variables you have, then we'll work back and find z later. Okay, so these two right here, I have a 9x and a 5x, and then I have a 5y and a 6y. None of them are going to eliminate nicely. We could make these opposite 45s. We could make these opposite 30s. Just because 30 is a little bit lower, let's go with this. So let's make this a positive 30. So I will multiply that by 6 times equation D, and then we'll make this one a negative 30. So I'm going to multiply this one by negative 5. Okay, so that's what I'm going to do here. So I'm going to multiply this whole thing by 6,